Alrighty, in this video, we are going to be talking about volume using the disk method. Now, so far, we have talked about finding the area between two curves, and we used rectangles. Essentially, finding volume is going to be very similar, where we are going to find the area and slice up infinitely many areas. For the disk method, this is used whenever the 2D area of the region is adjacent to the axis of revolution. That's going to be very helpful for us because then it's going to look something like this, where my cross sections are going to be circles, meaning that I am going to have infinitely many circles, and I'm going to find the area of those infinitely many circles. Now, because I have infinitely many circles, this essentially gives us my formula right here, where I have pi r squared, where r is going to represent my radius because the radius is changing. So here, this tells me that I have pi, the integral from a to b, of whatever my radius is. In this case, we're always going to do top minus bottom and then dx. Of course, if we do right minus left, we also have this formula right here. Same thing, except it's in terms of dy. All right, so looking at number one, we want to find the volume of the solid when y is equal to square root of x is revolved around the x-axis from 0 to 4. It already gave us my limits of integration of 0 and 4. And then I just need to find out what my radius is. So my radius, remember, is going to be top minus bottom. So my top is going to be the square root of x. My bottom is going to be 0, and then I'm going to square it. Now, you don't necessarily need the 0. However, I like it just so that you could see where it's coming from in terms of top minus bottom. I have 0 to 4, x, dx. Integrate that. You're going to get 4 squared, which is 16. 16 times I have is 8. And then if you do 0, that's basically nothing. So you have 8 pi units cubed. All right, same thing for number 2. We want to find the volume of the solid bounded by the region of y is equal to x cubed, y is equal to 1, and x is equal to 0 if the region is rotated about the line y is equal to 1. Okay, so notice how here, it already gave you the diagram, and we just need to find this intersection right here. Lucky for us, that intersection, if y is equal to 1, then x is going to be 1. Yay. So we have pi r squared. I have my bounds going from 0 to 1. And then we are going to do top minus bottom. So my top is 1. And then my bottom is going to be x cubed. That's going to be my radius. And then we have to do radius squared, dx. Don't forget about your pi. That's going to be your setup. Now, once you do that, you are going to go ahead and use your knowledge back in Math 1 to expand this. So you're going to get 1 minus 2x cubed plus x to the 60x. And then once you do that, you are going to integrate it. And we have our bounds of 0 to 1. All right, you should be able to do this without a calculator because that's just 1 minus 2/4 plus 1/7 times pi units cubed. The reason why is because if I were to substitute in 0, this is 0, this is 0, and this is 0. So there's certainly no point there. All right, so something like number 3, this is where you actually have to sketch out the diagram so that you know what the question's asking. So here we want to find the volume bounded by x is equal to y squared, x is equal to 1, revolves around x is equal to 1. Now remember that x is equal to y squared is going to be your sideways parabola. That looks something like this. And then you have your x is equal to 1. Now, I can't do top minus bottom here, so I'm going to have to use right minus left, which means that my differential is going to be dy. Because it's dy, I need everything to be in terms of y. If I were to do top minus bottom, not top minus bottom, right minus left, I have y minus, and then y square. And don't forget about your square right here. So this little piece right here in black is 1 minus y squared. Now, the only thing we need to do is find my limits of integration, which isn't going to be that bad because we know that x is equal to 1. So we're going to substitute that in there, which means that y is equal to plus or minus 1, which means that my bounds are going to be from -1 to 1 of 1 minus y squared dy. All right. Once again, you're going to use your Math 1 skills to figure out how to expand that. So that's going to be 1 minus 2y squared plus y to the 4th dy. And then once you do all of that mumbo jumbo in terms of integrating it, you should get 16 over 15 pi units cubed. Check my work. Hopefully that's right in terms of number 3. Okay, number 4, we want to find the volume of y is equal to x cubed, y is equal to 1, and y is equal to 8 revolved around the y-axis. Something that I forgot about number 4 is that it needs to be x is equal to 0 also, because that's on the y-axis. Remember that you can only use the disk method if you're if it's adjacent to the axis of revolution. Now, if I were to sketch this out, let's see, like that, it revolves around the y-axis. So x is equal to 0. We have y is equal to 8 right here. And then y is equal to 1, let's say, right here. Now, can't really do top minus bottom because there's really no top here. And then my bottom is going to be my cubic. Then again, there's not really a bottom. So I'm going to have to use right minus left in terms of my circle. So to find my radius here, I have right, which is going to be my x cubed. And then I have, oops, not x cubed. Since this is in terms of dy, I want to make sure that I have everything in terms of y. So it shouldn't be x cubed, but it should be y to the 1/3. So this is y to the 1/3, and then minus 0 because your y-axis is 0, and then square. That is going to leave me with y to the 2/3 dy. But, of course, we need to find my bounds of integration. And since they already gave me that y is equal to 1 and y is equal to 8, I know that it's going to be from 1 to 8. Okay. Once you do that, you are just going to integrate this. So up your power, that's going to be 5/3. So you're going to get 3/5 from 1 to 8, then pi. So whatever that is, evaluate it, and then call it a day. Whatever it is, units cubed. Okay, last one. Let's see number 5. We want to find the volume of the solid generated by y is equal to x squared of x, y is equal to 2, and x is equal to 0, revolved around y is equal to 2. So once again here, because we have y is equal to 2 as part of my region, and it's adjacent to my axis of revolution, I know that I could use the disk method. What I'm going to do now is actually try to sketch out what this looks like. So we have the square root of x. We have x is equal to 0. And then we have y is equal to 2. So we want to find out this region right here. Okay, so I could do top minus bottom. So my top is going to be 2, and then my bottom is going to be the square root of x squared dx. And then I just got to figure out what my intersection is. I know that I'm going to go from 0, but then my upper limit, we got to figure that out by substituting in 2 for y, which means that x is 4. So this is 4. So my setup for number 5 is pi times the integral from 0 to 4 times 2 minus the square root of x to the squared dx. Once again, use your algebra rules back in Math 1 to figure out what this is expanded. So that's going to be 4 minus 4 square root of x plus x, and then this is going to be dx. And then integrate that. What do you get? You should get 8 pi over 3. So you should be able to do this without a calculator. All right. And essentially with these types of problems, you're doing the same thing, making sure that your region is adjacent to your axis of revolution for this method to work. And then in the next video, we will talk about the washer method and see what happens whenever the region is not adjacent to my axis of revolution. That's the next lesson.